Hello, we're going to present you this concept, which is the free fall, and it is a very important concept in physics, but we don't know exactly how to use it in in a specific problem. So that's what we're gonna teach you today. So the free fall works mainly with three concepts that are the gravity, the velocity, and the distance. So
we're gonna make an experiment to show you how you could find all of the components of free fall with a pool, okay? Okay. Una, dos, tres! Okay, so gravity, it's an acceleration that it's 9.8 meters per second square, and it's what helps getting to the ground, okay? Then we have two types of velocities. There's the initial velocity, that is the starting point of the process, and then there's the final velocity. They're not equal because of the trajection. And then this trajection, it's called what gets them apart, and it's the distance between the initial and the final velocity. Okay? Got it?
As my partner said, there is the gravity, that is an acceleration, and it has two ways to be, the negative way and the positive way. So when the object is going upwards, there will be a negative acceleration, and when the object is going downwards, there will be a positive acceleration. That's because the gravity always pulls us down.
So in here we have what it's our initial velocity, and it's the force that our body is applying to get off the ground and to have an impulse to get a higher position. This is called our initial velocity, okay?
Upwards, the velocity will be always changing. That's because of the gravity, that it's always pulling it down. So there will be a point where the velocity reaches zero, and then the object will start to fall. The object then will reach a final velocity when it touches the ground, and that's a very important concept.
So to get every variable you want in your experiment, there's three formulas. There's the first one, second one, and third one. The first one, you use it to get final velocity. The second one, you also use it to get final velocity. And the third one, you use it to get y, as in distance. But if you want any other component or variable of each of the three formulas we have, you could isolate the variable you want to get it, okay?
So we're going to split up the problem in two. The first part of the problem will consist from when we jump to when we reach the highest position. So there are these variables that will help us to understand all the problem. The first one is the distance from where we jump to when we reach the highest position. There's also the time that we use to do this motion, and there's the initial velocity that we have when we jump, and the final velocity that you already know that is zero. That's when we reach the highest position. So
in the statement of the problem, it says that your final velocity is 0 and the gravity is minus 9.8 meters per second square, and you know that the time is 0.42 seconds. Then you substitute all the values in the equation to isolate the initial velocity, and then by the multiplication it is this value, and then you move the values in the equality to obtain that the initial velocity is 4.12 meters per second. Here you will obtain the value of y, that is the distance. For this you will have to substitute the values of the initial velocity and the gravity. And well, here you don't have to use the specific exact measurements of meters and seconds and everything, but at the end the result has to be in the units that are being asked for. Here you will multiplicate and write what you have to do so, and then we will obtain this value that we will pass to the other side of the equality, and then we will divide it to obtain that will the value of y, it's 0.85 meters. 0.86, sorry. Then, to obtain the highest reached position, you will simply add the value of 1.5 meters plus 0.86 meters, and that will be 2.36 meters, and that will be your highest reached position.
Okay, so your second equation is going to be a little bit different. You have that your initial velocity is going to be your zero from your last equation, and you have that the distance, it's going to be the distance that we gave you at the beginning and the sum with the distance that you got from your first equation. That's just going to be your distance. What you have to get is your time and your final velocity. But it's really easy, but we're asking also for the total time. So the total time, you're gonna get it from the first equation. You're gonna sum the first time and then the second time that you got from your second equation, and just gonna add it. It's really easy and it's really simple.
So here we're gonna obtain the value of t that is equal to the time, and well, we're gonna substitute the value of the initial velocity that we know that is 0, and y, that it's the distance that we have already obtained. And well, so then we substitute the values, and as a first step you will pass the 2 to multiply 2.36, and then you will divide that value over 9.8. That will give you time squared. Then you will have to obtain the square root of 0.48 to obtain the value of t. That will be 0.69. Then to obtain the total time, you will simply add the value of 0.69 seconds plus 0.42 seconds, and that will be 1.11 seconds. That's the total time. So to obtain the final velocity, it's a very simple procedure, and well, we will start with the equation that states that final velocity is equal to initial velocity plus g by t. So the final velocity we know it, and the initial velocity we know that it's 0 because it's when the object starts to fall, and well, the gravity will be plus 9.8 meters over seconds per second squared, and that's because it is positive because it is when the object is getting down. So well, the time will be 0.69 seconds. That is what we got at obtaining the time. And well, you may question why is not the other time that was 0.4 something, or why it isn't the 1.11 seconds. And well, that is because this 0.69, it's the time that the object, or well, the person, it's getting from the highest position to when it reaches the floor. So that's what they're asking to you, that specific moment. Then you just substitute the values, do the multiplication, and then you will have that your final velocity is 6.76 meters per second. And well, that's all the measurements. These are the results, the final results of the problem. And well, that was all. We hope that you have liked the video and that you have understood everything, and well, see you.
Well, like the position, you know.
That we need to show it.
Yeah, we'll reach a final velocity. Okay, we'll have to record it again.
First thing we need is no. ¿Estás grabando, verdad?
Sí.
No. Want to find out the.
Nos tenemos el tiempo y qué más. And there's. Listo, ya está.